A very good morning to one and all present here. I'm Dr. S. Jaypurni, Professor in EC Department at Sri Shanmuga College of Engineering and Technology. Today we are going to see about structural testing in VLSI. Structural testing in VLSI focuses on verifying the physical and logical structure of a chip rather than functional behavior. It aims to detect manufacturing defects that occur during the fabrication, such as opens, shorts, and bridging faults. These tests are essential as modern ICs contain millions of transistors, making manual testing impossible. So that is the reason we go for structural testing. This structural testing can be performed in various stages of developing the chip. Miniaturization of any device or any product, it increases the probability of defect. It ensures so the chip reliability and performance, all this has to be tested at various stages of fabrication and at various stages of manufacturing. So, when the structural testing is performed, it reduces test time and cost compared to the functional testing. It helps to find specific physical defects rather than pure logical errors. And moreover, when structural testing is done at various stages, it ensures high yield in manufacturing process. Second fault. Look at this diagram. A line in the circuit is permanently stuck either at 0 or at 1. This is the most widely used fault model. So look at this. So there are two inputs 0 and 1, and here also we have 1 1. So what is the expected output? The expected output of this gate is 1. But what happens is here since it is being stuck here, the actual output is 0 here. So there is when anything happens like either an opens or shorts or anything that would happen in this line would make the actual output go wrong, and finally we get an very wrong output. Open fault. So look at this here. When a circuit is open, a connection is broken. So it will lead to the floating signals. So see here the two inputs of C1 and C2 are 0, 0, 0, 1, 1, 0 and 1, 1. So here what happens here is since the in this circuit it is open, instead of the expected output we get an output which is not desired. So what would happen at finally at the fabrication process? Due to this open fault type of signals, we get a defected output. Bridging fault. When two signal lines get shorted unintentionally, it causes logical errors or multiple driver conflicts. Here we see that where the line X and Y is being shorted. Here we have an NAND gate, a NOR gate, but the expected output will be completely different and than the actual outputs. So since the both the lines are being shorted, we get a defected output. So in order to overcome all these processes, we have a built-in self-test, BIST. Here the testing logic integrated into the chip itself, that is LFSR, is being linear frequency shift register, which is a pattern generator is being used, and MISR refers to the multiple input shift register, which is a response compactor is being used here. Okay, So see here, this is my BIST controller, that is built-in self-test controller. Here we have a start list and BIST is done, and it will help to identify whether it is pass or fail. Scan-based testing. Flip-flops are converted to scan flip-flops. They form a shift register chain for easy pattern loading here. So I have a combinational logic circuit, a functional data from scanning out input, from scanning enable port, then I have a clock. So see here, a scan-based testing is being performed here in order to identify the. So these are the various applications of structural testing, that is a microprocessor, DSPs, communication chips, SOCs, that is system on chip testing in mobile processors, MBIST, that is memory testing, automotive and medical grade chips where reliability is highly critical. All these are all done at various, the chips are being processed at various points by making use of these structural tests. Thank you, one and all.